Hey everybody, Dave Igo here. Another quick video about tips and tricks for tube laser. This is going to be about tube laser normalization, and you hear me talk about normalizing the cut all the time. And I wanted to do this video to help everybody understand why you hear me talk about it and why it's so important. So this is pretty representative of a tube that I just did for a project I was working on. And you can see there's a couple of cuts in here. No big deal, right? Slot there and triangle out here on the end. Okay, so what those are for, this is a function of the product, let's say. This is a fixturing recess. This keys into a pin in the fixture. And what it does is it sets this tube in a certain orientation because these slots have to be clocked a very certain direction for this thing to work. Normalization. So let's just let me open this real quick here. So this is the sketch that creates that notch. Okay, so there's going to be a 1/4 inch dowel pin, and we wanted to put a triangle. I always use a V notch whenever I'm keying to a dowel pin instead of a half round. And you know what? Check out some of my fixturing videos and I'll explain why I do that. But so this is what this looks like, and it's this sketch, and it just comes up and it makes this cut in the tube. The problem is, alright, I gotta go off on a little rant here. Okay, most of what I'm showing you, and talking about is a 4-axis laser. Okay, now in a situation like this, a 4-axis laser. Okay, first let's define some axes. You've got an X, a Y, and a Z. Okay, now this isn't oriented. The way this actually sits in the tube laser is this is our X, our Z is the head up and down, and our Y would be across the tube. We've also got a rotational axis, which is the A axis. Okay. Now, when you go to cut a hole like this slot, you can cut in what's called XY, which means the tube still feeds in and out to get the X, but instead of the tube rotating, it moves the head back and forth. Okay? So in this situation, you could actually cut a slot that looks like this. Now, on a thick-walled tube like this, you're not going to be able to do it. Okay? You're going to put so much heat to the inside of that tube. And if I just change views here and go over to this view and go to the end, let me normalize this. Okay, so this is our slot right here. Okay, so you just don't have enough clearance in here. You're going to pump so much heat into this tube doing it this way that this slot's just never going to cut. It's never going to be clean. Now, if this was a thinner walled tube, if it was half this wall thickness, and incidentally this is a 1/4 wall. It's a 1-inch 1/4 wall tube, and we're putting a 1/4 inch slot in there. So we've got, on the numbers, an 1/8 inch on either side of that cut, but it's just not enough room to get rid of the laser slag. So you can't really cut this in quote-unquote XY mode. Okay, you're going to actually spin the tube to get the cut. So instead of using the Y axis, you're going to use the A axis and spin the tube. Now, the problem you run into when you're doing that is that your cut actually winds up looking like this. Okay, so this is what you're really going to get coming off of a 4-axis tube laser. Now, there's places out there that have 5 and even 6-axis tube lasers that can angle the head, and they can do all kinds of things, and normalization's not as big an issue with them. However, on this particular part, it wouldn't matter because our heat is the issue. So we have to point the laser beam. Let me highlight that line. We have to point the laser beam at the center of the tube. It's the only way to get a good clean cut. Okay? So this is tube laser normalization. This is what this thing's going to look like. Also, my tooling guy is going to put a dowel pin right here to key into this thing. So he needs to know exactly what it's going to look like. So knowing how to normalize a cut on a piece of tubing in Solidworks really becomes pretty critical. And there's ways you can do it. You know, you can put a lofted or a swept cut in if you want to try and draw that geometry, but wow, I wouldn't want to do it. I suppose you could try and screw around with a taper on the cut, but if you look at, because as the X translation slows down, in other words, as you start coming around the corner, okay, you don't have any taper in it, so the tapered cut thing really wouldn't work. So Solidworks doesn't really provide functionality, in my opinion, to do this quickly. Now, you guys have heard me talk about I'm half a renegade when it comes to the way I model a part. I freestyle around and I'll take whatever shortcut or cheat I can. Sometimes it upsets the CAD guys, but for most of the stuff I'm doing, which is welded steel, I'm not doing a lot of machining, so there's not a lot of CAM programming being done off my parts. This works just fine. So I want to show you how I do this, okay? This is a tube that I'm using in a current product, okay? And every single thing has a function here. Now, you're going to notice, as modeled, right, I've just got sharp cuts through here because it was derived from an assembly. And my cuts, obviously, my 4-axis tube laser is not going to put this angled cut in this tube. I know it's not. I don't need it to. But this is how it's modeled because, you know, as it sits in the assembly, like this, I've got to cut through 50 things, okay? So you can either go back and try and figure out how to do this, or you need a quick trick to do it. So now let me show you this real quick. This is something that I figured out. I think I'm the only one who's figured it out. Probably not, okay? Do you see that? So that's what that corner is really going to look like. It's not going to look like that as modeled. It's going to look like that as cut from the laser, okay? Pretty cool magic trick, right? Bet you didn't see that one coming. Let me go back here. Let me show you this end. So this is how I've got it modeled, right? Watch the difference. That's what it's going to look like, okay? Now, how do you do that in SolidWorks? Well, again, this is one of those cheats that I think everybody who models for tube laser probably should know. So that's why I'm doing this video. I think this is a pretty cool trick. So what's the first thing I do? I come in here on the front plane and I put a sketch. I cut that thing open the whole way. Make sure it's not going through any features that you want to save, right? Here's the best part. What's next? Convert it to sheet metal. How simple is that, right? Now I want to show you something. When you do your convert to sheet metal, you have to click the inside face, okay? Let me show you something. What happens if I click an outside face? It's not going to let me. I'll get into that some other time. There's a reason it won't let me. It has to do with the way that the bends were selected. But anyway, convert to sheet metal. Now, it also, when you convert to sheet metal, it puts in some goofy bend reliefs that you can't get rid of. So you have to come back in and just either put extrudes or lofts back in to fill them in. That's such a great tip, guys. I'm telling you, here's another thing. Let me show you something else. Let me just open a new drawing here real quick. And let's go back over to our model and go back to our as drawn view and go back to our paper. So now let's put some dimensions on here because we got to give our quality people something to check, don't we? I think so. Okay, so I got 416 millimeters, just about 417 there, okay? But I know that the way the tube laser is going to cut this thing is actually going to be like this. So that's a 10 millimeter difference. That's a ½ inch difference, okay? Sometimes it's going to be important to convey that information to your quality department or whoever's got to check the part, whether it be the operator or the quality department. But that's important. So I wanted to do this quick video just to show you what I'm talking about when I'm constantly talking about tube laser normalization. Just incidentally, just so you know, typically what I would do on this part as far as a print goes is I'm pretty confident in equipment. If it's CNC equipment, whether it's a tube laser, sheet laser, a turret punch, milling or turning machine, whatever it is, except a press brake and a tube bender, that's a whole nother video, I'm pretty confident in it. So I will usually say, once I've built a prototype and once I've proven this part out, as long as I've got good procedures and good lockdowns and my rev control, I'll trust my laser program. In which case, I'll give the quality department a few checks, IDs and ODs, just to check laser offset is really what it comes down to. So I'll probably measure across here. I'll put some tolerancing on the bolt pattern, not that it's going to move around again. Your corner radius comes into effect here a little bit, so keep that in mind. If you're toleranced close to an edge, that can really screw some things up, so always keep that in mind. Anyway, this is Dave Igo. For all of my tips and tricks for tube laser, I want you to go over to my personal website, daveigo.com. That's Dave Igo, IAGO.com. Check out my portfolio page, ask me a question, anything I can do to help. So I'll see you in the next video. Thanks, guys.